An antenna is the structure that lets electrical energy in a circuit leave the wire and travel through space. In this lesson, an electromagnetic wave, or EM wave, means a coupled electric and magnetic disturbance that moves away from the source. We will stay intuitive first. The goal is not a full Maxwell derivation yet. The goal is to build a picture that makes the later formulas feel motivated instead of mysterious. Once that picture is clear, the rest of antenna theory becomes much easier to trust. Start with a dipole fed by an alternating current or AC source. As charge oscillates back and forth, charge separation develops across the two arms. That creates a change in electric field or E field between the conductor regions. Because the electric field changes with time, a magnetic field or H field appears around the current path. Then the change in magnetic field supports a change in electric field again. This time-varying loop is the core intuition behind radiation. The message is simple. If the fields keep changing in the right way, energy no longer stays trapped near the wire. It can propagate away. Many textbooks draw an apple-like or lobe-like picture for a dipole. That picture is helpful, but it is only a two-dimensional slice through the full three-dimensional radiation region. In full space, the strongest radiation wraps around the dipole and forms a torus-like or donut-like shape. At the same time, radiation is weakest along the dipole axis itself, so the flat slice is not wrong, but it is incomplete. This is exactly why light three-dimensional animation is useful here. It resolves a spatial misunderstanding that static sketches often leave behind. Now place a conducting ground plane under half of the dipole. That gives the key intuition for a monopole antenna. The missing lower half can be treated as an image in the ground, so the visible vertical rod behaves like half of a dipole above a mirror. This is why a monopole can still radiate efficiently while using only one physical arm above the surface. For this lesson, the image idea is enough. We do not need the formal mathematics yet. We only need to see why the monopole picture is so closely related to the dipole picture. This is also why antennas matter so much in communication systems. A circuit can generate information, but an antenna lets that time-varying electrical behavior launch into space and reach a distant receiver. Later, modulation explains how information rides on a higher frequency carrier. But before we talk about those communication details, we need this antenna picture. No change in fields means no radiation. No radiation means no wireless link. So this lesson is the foundation that connects field intuition to the practical idea of sending energy and information through space. In the next lesson, we build on this intuition and examine radiation patterns more carefully using E-plane, H-plane, gain, and directivity. For now, remember three pictures: the dipole, the full three-dimensional torus-like radiation shape, and the monopole above ground.